So for question 28, they give us a piecewise function. So they ask us if the limit approaches the function gx when x approaches 2 axis, what's the value of m? So for this piecewise, we have to draw it first. Make sure we clear about the interval. So for interval 2 less than 2, it will be m squared minus 8. And then after 2 to 8 here, it will be the function x minus 2 over square root 2x, then minus 2. And then more than 8, you have a modulus function here. So later we have to do our piecewise function, do our modulus, express it in the piecewise function so that we can use the correct. So for this part A, we just focus at value 2 here. So this one I remain 8 minus modulus x minus 8 plus k. So they said limit for this part x approaches 2, it is axis. So means that limit from the left hand side and limit from the right hand side, it must be equal to each other. So from there, we find out what is our, for that concept, we find out our value of m. So since the limit axis, so we are doing limit for x approaches to left hand side, which is function m squared minus 8, is supposedly to be equals to limit for x approaches to from the right hand side for the function x minus 2 over square root 2x minus 2. Then we try to do our limit. We attempt our limit. Can we substitute? Yes, we can substitute here with, although this don't have x, so our value is constant, m squared minus 8. So how about we substitute this x value? 2 here is 0. So this one also 0. So it will be give us IDF 0 over 0. So we have to simplify our function first before we attempt our limit. So we can see our function here, it is in third function. So for third function, in order to simplify its IDF, we will multiply with its conjugate. So its conjugate will be square root 2x plus 2. And we only simplify for the part which is its conjugate. So a minus b, a plus b. When you multiply it together, it will be a squared, which is give us 2x, and then minus b squared, which will give us negative 4. So up here, it will remain is in the form of bracket, in the form of multiplier, in the form of factor. Then we try to factorize again so that we can simplify. So our denominator part, we can factorize the value of 2. Then we can get to the same factor. Our function is simplified. So after we simplify our function means we can attempt our limits. So substitute our x equals to 2. Will become square root of 4 plus 2 over 2. So it will give us m squared equals to, so plus 8. So it equals to 10. And then simplify our square, it will become square root, positive, negative. So we have two answers here. Positive third 10 and negative third 10. So this is our first concept where we know that limit, when you want to find limit axis, limit left hand side and right hand side, it must be equals to each other. The answer, the result of these two parts must be equals to each other. So for this right hand side, we need the IDF form. So we have to know the concept to simplify IDF involving third is doing its conjugate. And then simplify the conjugate. Simplify the conjugate and then simplify the function here to get to the answer. For part B, so they said find the value of k such that this function is discontinuous. So we want to challenge the part here where it cannot be continuous. Discontinuous means not continuous. So when we said here they cannot continuous, so means that the left hand side and right hand side they cannot equal to each other. So definitely here we cannot make it equal. If they're equal, limit left hand side, right hand side equal, so it might be continuous already. So then now the situation here, they say discontinuous, don't want to make it equal. So for this part, when we see we have a situation of modulus function, we simplify our modulus function. We express our modulus function in piecewise. So our modulus function for 8 minus x, we express it in piecewise, it will be positive. For this more than equals 0, it will be negative for this less than 0. So we have to choose a correct function in the interval. So simplify the domain here. So we move the 8 to the right hand side. And then simplify some more. Divide by negative, so it will be changed inequality sign. So we look at our interval again. For this 8 to the right hand side, so more than 8. So more than 8, our function involved here supposedly it will be equals to this. So this is our function involving in our piecewise. So when you say it, it is discontinuous, so I will make sure limit what x approaches 8 from the left hand side. So left hand side is this function. Cannot equals to limit when x approaches 8 from the right hand side. So our 8 from the right hand side, it will be this function. So make sure you use the correct modulus. Correct modulus is this negative modulus over. Okay, so this is the information they give us. Discontinuous. Automatically know condition number 2. Limit cannot exist. Limit cannot exist. Left hand side cannot equal to right hand side. Find the value of k. So now we're going to proceed. We try to attempt our limit here. We substitute our 8 here. So we can do our limit. When we substitute 8 here, 8 minus 2 is 6. And then 8 times 2 is square root 16. Square root 16 is square root 16 minus 2. Cannot equal to this part. When I substitute 8, it will be 0 over 0. So this is IDF. We have to simplify the function before we doing our limit. So try to factorize out the negative. Then I get negative 8 minus x. Oh, it is same. Okay, so this is same. Just the order is indifferent. So I write it in order x minus 8, x minus 8. When I write it in order, then we can see it clearly. So the whole factor is same. We can simplify. So this is 6 over square root 16 minus 2. So it is 3. Cannot equals to the limit for x approaches 8 from the right hand side for a constant. So when we have a constant means the limit is equals to k. So constant 1 plus k. So when you simplify here, you remember we still have a 1 here. So 1 plus k. So our k cannot equals to the value of 2. Means you can put any value of k, but it's not 2. When you put 2, they will make it it will make it continuous. Find the value of k such that this function is discontinuous. So whatever value of the k it can accept, but accept value of 2. Once you put value of 2 here, it will make this function continuous. So any k cannot equals to 2 only. So from here, this is our concept to make it discontinuous from left hand side not equal to right hand side. So choose our correct function in our piecewise and simplify it to find out the k value.